Hi, and welcome to this tutorial on resolving a force. And basically what this is about is that if you've got a particle and you've got a force acting on your particle, illustrated by this green arrow here, what we can do is split this force into two other forces at right angles to one another, often called components. These two forces will replace this single force. They'll have the same effect as the one force. And you'll often find that by doing this in problems involving mechanics, involving forces, helps to simplify the problem. Now, I always kind of think of this as like two ropes being attached to a particle. And if you were to pull in these two directions with two forces like I've got here, you'd expect your particle to move somewhere in the middle here, okay, depending on how strong these forces were. If this force was a lot stronger than this one, the particle would move somewhere along here. But if this one was a lot stronger than this one, it would move closer to the vertical. But what I've got here is that we've got these two forces here which are going to replace this force here. And in this tutorial I'm going to show you how you can work out the size of these components, which you're going to often need to do when you're given this single force here. And I'll show you how this is done. So far what I'm saying is this force is equivalent to or identical to two forces at right angles. And let's say that we call this force F newtons. Then we've seen, well, I'm showing you that you can split this into two components. And what we can do is we can take the first component. Let's just take that one, just move it over here. We can take the blue component and we can put it on the end like this. So we have our red force followed by our blue force. And what this gives us is, as we've seen, this green force here. We can bring this force over here and put it in that triangle like that. We have what is often called a vector triangle of forces. This force, the red force, followed by the blue force, the sum of these two components is exactly the same as this resultant force through here, F. So let's just label that up, okay? This is F newtons, and we've got our components. Let's say that we call this one R newtons and we'll call this one B newtons. R for red, B for blue, okay? Now let's say that this force here acts at an angle to the horizontal. Just mark a horizontal in here. And let's say this angle in here is theta degrees, say. So that means that this angle in here would be theta degrees. And by using trigonometry, we can actually work out, knowing F, knowing this angle, what the two components are. Let's see if we can work out what the red component is. I'm assuming you're familiar with trigonometry. That is where this side is the adjacent side to the angle theta, this is the opposite side, and this is the hypotenuse. And if we wanted to work out r, we would turn to the cosine function. We would have that the cosine of the angle theta equals adjacent over hypotenuse, the adjacent over the hypotenuse. And the adjacent then is r, and the hypotenuse we can see is F. And if we rearrange this by multiplying both sides by F, we end up with R equals F times cosine theta, F cos theta for short. And we can do exactly the same for this component, the blue component over here. Figure out what B is by looking at the sine ratio, because this side is the opposite side to theta and this is the hypotenuse. So sine of an angle always compares the opposite side to the hypotenuse. So the opposite is b compared with, divided by, the hypotenuse f. And if you multiply both sides of this equation by f, you find that b turns out to be f sine theta. So we can mark in these two components. We can see the size of them. So we've got the red component here is f cos theta, and that will be measured in newtons, and this component, the blue component, will be f sine theta newtons. So our single force F acting at an angle theta can be represented then by these two components, and this would be the size of them. If I was to draw that F back in, let's just put it back in, it's going to be a line something like this, okay? There's our F newtons, and we've got our angle theta here. Now, what I want to point out to you is that you're always going to find yourself having an angle contained between the resultant force here and one of the components. And the one that contains the angle is always the cosine, f cosine theta, and the one that excludes the angle, as you can see, this doesn't have the angle in here, is always f sine theta. And if you can remember this, it makes working out your components of a force at a certain angle very, very easy. Now let me show you. Let's just suppose we had an example like this, that we've got a force, say, of 20 newtons. Let's say we've got 20 newtons acting in this direction. Now we can split this force into two components at right angles to one another. One in this direction and one in this direction. Notice that the force that we've got is somewhere in between these two components. And let's suppose that this force makes an angle of, say, 60 degrees with this red force. Okay, now I know that this angle in here would be 30 degrees, but just let's leave that out, okay? Let's just work with the 60 degrees. So you'll see that the 60 degrees is contained between the resultant force of 20 newtons and this force here. It's contained here. In this one, on the blue force, you'll see it's excluded. There's no angle in there. We haven't written the 60 degrees in this space. What I'm trying to say up here is that when it comes to the components, the one that contains the angle is going to be your force, 20 newtons in this case, times the cosine of your angle. So this component here will be 20 times the cosine of 60 degrees. And you could work that out on your calculator and you could see how much force that is, okay? And this component, it doesn't contain the 60 degrees, so therefore it's excluding the 60 degrees, so it is the sine of the angle. So this force is 20 sine of 60 degrees. This force is in newtons, and the other force here is in newtons. Let's do it one more time, okay? Let's try another example. Let's suppose we have 8 newtons. You can actually do this one, alright? And you can pause the video in a moment and just try it. What we've got is a force of 8 newtons, and we can split this into two components. We can have one, say, in this direction up here, and another one at right angles somewhere down here. Okay? Two forces, one in this direction, one in this direction. We need an angle in between this force and either this or this direction. Let's suppose we have this angle in here. Let's suppose that that angle in there is, say, 65 degrees. Okay? Now your job is to tell me what is this component going to be and what is this component going to be? So you might like to pause the video for a moment, just think about that. When you're ready, just come back and I'll run through this with you. Okay, welcome back. How did you get on with this? Well, our two components are at right angles to one another. One contains the angle of 65 degrees and the other excludes that angle of 65 degrees. So the one that includes the angle is always cosine, so this component here is going to be 8 cosine of 65 degrees, and that will be measured in newtons. And this force excludes the 65, so it's going to be the sine of 65, 8 times the sine of 65 degrees, and that will be measured in newtons. Now I know you could work out this angle here, and I know it's 25 degrees because it all adds up to 90 degrees, and you could say that this was 8 cosine of 25 degrees. But I would strongly discourage that, because in problems you might just have this angle as theta, and it's much better to write 8 sine theta rather than 8 cos of 90 minus theta. So I'd always encourage you to work with the angle that you're given. Okay, well I hope that has been of some use to you, and in my next tutorials that follow I'll show you how we can use this concept of resolving to simplify problems.